Okay, so now what we're going to be taking a look at are vectors. Okay, this is chapter 3 in your Holiday and Resnick book. Vectors are all through physics, and they're used ubiquitously throughout the entire course, throughout the entire subject. And they are extremely important, and their properties are extremely important to what we do. What we're going to be doing here now is going over some of the basics of what a vector is, and go over a couple of things that we have taken a look at in the past, and some other things that we haven't taken a look at in the past. The first thing that I want to talk about, what is a vector? Okay, a vector is a quantity that has both magnitude and direction. Okay, it is so if you're talking about temperature, temperature does not have a direction. You don't say that it's 32 degrees in that direction. You just say that it's 32 degrees. However, if you're talking about velocity, velocity is a vector. You're going 25 miles per hour in that direction. That is a vector. Okay. Speed, on the other hand, is not a vector. Okay. It's its scalar counterpart. Scalar is a quantity that has only direction. So now, let's take a look at a situation here where we want to add two vectors together. Okay, and the first thing that we're going to do is take a look at this geometrically. Last year we didn't take a look at it geometrically so much. We did it quantitatively, and there are lots of tools that we can do to try to simplify things down a little bit. Okay, so let's take a look at these two vectors here. I've got vector A, might be a little bit faint, and vector B that are lined up head to tail. Okay. They are, as opposed to these two vectors, which are lined up tail to tail. Okay, so now when they're lined up head to tail, it's very easy. Okay, you go for, think about Bob walking. Okay, person starts here, Bob walks from here over to here, and then over to here. His displacement then would be that. Okay, this would be your A plus B. Now, when you're talking about two vectors that are lined up tail to tail, okay, it's not as easy to see how these two add together, but it's a very easy method to do it. But what we can do is essentially move these vectors. So I could take B here and move it over here, okay, so that they are lined up head to tail. Vectors can be moved, okay, or I could take A and move that to the head of B, and we get that. Okay. Notice that when you move them, they are still parallel to each other. Okay. They don't go in some weird direction. So when we add these together now, whichever way we go, this way to here, this way to here, you wind up at the same spot, and this would be my A plus B. Okay. I should have vector hats on top of all of those, and here as well. Okay, so that's how we do vector addition graphically. Another way that we can look at this, by the way, when they're lined up head to tail, okay, if I take any two vectors like this, really what I'm going to do is make a parallelogram. So if I want to know how these two line up head to tail, well, basically what I'm going to do is make a parallelogram, and I mean to make this almost 90 degrees. There's my parallelogram from these two, and there's my A plus B. Okay, so that's how we add these two vectors graphically. Okay, something that I should point out here. I went A plus B this way. This way I go B plus A. Okay, if I flip the order on this, on these two that are lined up head to tail, okay, I will also wind up with the same vector. Okay? It doesn't matter which order you go in. You could add vector A to vector B and get one result. You add vector B to vector A, you get the same result. It doesn't matter the order. Okay? To subtract two vectors, okay? If I take, and there's a graphical shortcut too, but the basic idea is this. If I have a vector that goes like this, vector A, and another vector that goes like this, vector B. And I want to subtract these two vectors. Okay. So now, I want to get A minus B. Well now, vectors can be moved, okay? And I'm going to have to move B here. The idea is B, what I have to do here, this is like saying the same thing as A plus a negative B. Okay? I'm just going to take this, I'm going to flip it over. So now if I flipped it over, okay, and I make a point in the other direction, well now they're lined up. Now they're lined up head to tail. Excuse me, tail to tail. So when I add them, I have to use parallelogram method. And that would be my A minus B. Okay, because I'm adding A to a negative B, and it works out to be the same. Okay, so that's addition. Let's do the geometrical method of adding vectors. All right, so now let's get into a little bit more of the meat of this, where we start getting into some of the more analytical methods. We're going to take a look at components. Okay, so now, really what we want to do, let's just say that I have an axis like this, okay, and I have a vector. Well, it goes like this. Okay, I'm going to call this vector A. Well, now this has components. It has parts that go both along the x direction and the y direction. Okay. This part right here is going to be the AX. This part right here is going to be the AY. I need an angle theta here to be able to figure out what they are. So now, if I take a look at this, the x component, AX, it's the part that goes along the x-axis, the reference axis here. It's going to be A cosine theta. Okay? So the x component of A is A cosine theta. That's going to be this part right here. AY is going to be A sine theta. So now, that's if I want to get from A to AX and AY. Let's say I want to go in the other direction. If I want to get A from AX and AY, in other words, I want to get the vector from the components, well, the magnitude of A will equal AX squared plus AY squared. Now that gives me the magnitude. Doesn't give me the direction. The other part of it, okay, is the direction that's given to me by the angle theta. Theta will equal the inverse tangent of AY over AX, the inverse tangent, okay? So I take the y component over the x component, okay? That gives me theta. So now, that's a lot of the stuff over here. This is stuff that we went over last year in quite some detail. And we're going to talk about adding vectors a little bit more when we get into unit vectors, which is going to be the next unit. So, actually not next unit, the next lecture. So we're going to stop there.